everyone, welcome to today's video on collecting like terms, where I will be explaining a bit about what that means and then also be going over some examples with you guys. So first off, like terms are terms with the same variables raised to the same powers. So what do I mean by that? You need to have the same variables. So for example, 3x and x would be like terms, but they also have to be raised to the same power. So 3x squared and x would not be like terms, but 3x squared and x squared would be like terms. So I'm going to go over a few examples of like terms with you right now. So in our first example, we have x, 2x, 100x, negative 5x, and 3 over 2x. So these are all like terms because they share the term x, which is to the same power, all to the power of 1. So for our second example, we have 9 root x, root x over 2, negative root x, and x to the power of 1/2. So if you remember, x to the power of 1/2 is the same thing as root x. So those two are interchangeable. So for this guy over here, this is the same thing as 1/2 times root x. So all of these examples have the same variable raised to the same power, which would be root x, which is also the same thing as x raised to the power of 1/2. And in our third example, we have 6a squared b, negative 3a squared b, and b times a squared. So remember, like terms have the same variables raised to the same power. So 6a squared b and negative 3a squared b are like terms because they both have the same variables, a and b, and they're raised to the same power. So the a is raised to the power of 2 and the b is raised to the power of 1. This third one over here is a bit mixed up, so it has the b first and then the a squared. But if you remember with multiplication, the order you multiply doesn't affect your product. So because of this property, also known as the commutative property, this is also a like term because it also has an a and a b, where the a is raised to a power of 2 and the b is raised to the power of 1. So all three of these would be like terms. And being able to recognize like terms and then collecting them and either adding or subtracting them allows you to simplify expressions. And I'm going to go over a few examples with you in just a moment on how to do that. So for our first example, we have 4m plus 5m squared minus 3m plus m squared. So our first step in simplifying this would be to collect our like terms. So we need to figure out which terms are like terms. So 4m and negative 3m would be like terms because they both have m's raised to the power of 1. And remember, you have to carry that sign that is in front of your term. That is a part of that term. And 5m squared and m squared would be like terms because they both have m's raised to the power of 2. Now that we've collected our like terms, we can simply add them together to get our simplified expression. So 4m minus 3m is just going to be 1m, so just m. And 5m squared plus m squared is going to be the same as 5 plus 1, so 6m squared. And we like to write our expression in order of descending exponent. So we like to go from highest power to lowest power. So we're going to write 6m squared first, followed by m afterwards. And then that would be our final answer. Question 2 is a bit longer, but it's the same concept. So we have negative 2u plus 3 minus 5u squared minus 1 plus 2u plus 3u squared and minus 3. So the first thing I'm going to do is gather our u squares together because it's our highest power. So we have negative 5u squared and a positive 3u squared. Now in another color, I'm going to gather our u's. So we have a negative 2u and we have a positive 2u. And those cancel out because we're adding 2u and subtracting 2u. So that leaves us with 0 u's. And then in another color, I'm going to grab our constants or collect our constants. So we have a positive 3, a negative 1, and a negative 3. So the positive 3 and the negative 3 would cancel out, and that just leaves us with a negative 1. And now we can simplify our expression. So negative 5u squared plus 3u squared is going to be negative 2u squared. We don't have any more u's because they canceled out. And then we're also left with our negative 1 from here. So this would be our final answer. And for our third question, I'm not going to read it all out, but we're going to gather our like terms. So in red, I'm going to grab our x squared. So we have 3x squared, a negative 4x squared, and a positive 2x squared. In blue, I'm going to grab our xy's. So we have 2xy, we have a negative xy. In purple, I'm going to grab our y squared. So we have a negative y squared. And lastly, in green, I'm going to grab our constants. So we have a positive 2 and a negative 3. And now I'm going to simplify. So I'm going to start off with our x squared. So we have a positive 3x squared, a positive 2x squared, which would make 5x squared. And then we have a negative 4x squared, which would just be 5 minus 4. So we're left with 1x squared. Now I'm going to do our y squared, and there weren't any other y squares, so we're just left with negative y squared. Now I'm going to do our xy's. So we had 2xy minus xy. So that's just 2 minus 1. So that's going to be positive xy. And lastly, in green, we have our constants, and that's just 2 minus 3, which is negative 1. So our final answer would be x squared minus y squared plus xy minus 1. And now for one final question, I thought I'd do a word problem. So the length of a rectangular field is 4 times its width. Part A asks us to write an expression for the perimeter of the field. So the perimeter of anything is the length of all the sides added together. So if we have a rectangular field, our perimeter is going to be our length plus our width plus our other length plus our other width. So if we were to write an expression for our perimeter, let's call that P, our perimeter would be equal to 2 lengths plus 2 widths. So that would be one expression for the perimeter of a field if we know both the length and the width. But our question also gives us some more information. It says that the length of the field is 4 times the width. That means 4 of these widths would make up 1 length. So we could illustrate that kind of like this. So 4 widths would be 1 length. So what that means is L is equal to 4 W's. So we can actually sub this into our equation over here and get another equation for the perimeter of our field, but in terms of just our width. So subbing that in, we get 2 times 4W plus 2W. And we can actually solve that, giving us 2 times 4, which is 8 W's, plus 2 W's, which gives us 10 W's. So perimeter is also equal to 10 times the width. So part B tells us to find the perimeter if the field is 250 meters wide. So right now we only know what W is. So we can't use our first equation for perimeter because that requires us to know the length. So we're going to need to use our second equation for the perimeter, which was only in terms of width. So we're going to use the equation P equals 10W. And since we know that W is equal to 250 meters, we can solve for P. So I'm going to plug that in right now. And don't forget to write your units when you're solving your problems. So that gives us an answer of 2,500 meters for our perimeter. And now part C wants us to find the length and the width of the field if the perimeter is 1,800 meters. So once again, we can't use our first equation because that has length and width. And if we have 2 variables, we can't solve. So for that, I'm going to use our second equation where perimeter is equal to 10 times our width. Now it's a lot easier to solve for W, as all we have to do is divide by 10 on both sides, and that leaves us with our width is equal to 180 meters. Now that we know our width is equal to 180 meters, we need an equation where we can solve for our length. And our first equation, P equals 2 times our length plus 2 times our width, allows us to solve for length since we know our perimeter is 1,800 meters and we know our width is 180 meters. So since we know those 2 variables, we can solve for our remaining one. So then we get 1,800 meters is equal to 2 times our length plus 360 meters. And we want to isolate our length. So we need to get rid of this positive 360 meters. So we're going to do that by subtracting 360 meters from both sides. And that gives us 1440 meters is equal to 2 times our length. And then to isolate L, we need to divide by 2. And then what we do to one side, we must do to the other side. So that leaves us with length is equal to 720 meters. So now that we know our width and now that we know our length, we have answered the question. I hope you found this video helpful, and I'll see you shortly in the next video. Thank you so much for watching.